Hello everyone, welcome back to my channel. So in this video we are going to learn about XS3 code. Okay, XS3 code and also about self-complementing codes. Okay, self-complementing codes. Right? If you are first time to my channel, please consider subscribing and hit the bell icon to get video notifications from my channel. Right, so XS3 code. So what is XS3 code? The name only specifies XS3 means plus 3. Okay, so XS3 code is equal to BCD plus 3. BCD plus 3. So that is BCD plus 0011. Okay, so this code is called as XS3 code. Okay, it is 3 in excess of BCD. It is 3 in excess of BCD. Okay, so let us write decimal equivalent and let us write in the form of table. Okay, so decimal XS3 code. Okay, so the representation of 0. So for 0, so BCD is represented in 0 as 0000 plus 0011. So XS3 code of 0 will be 0011. Okay, so BCD code of 0 is 0000. So 3 must be added to it. So for every number you have to add 3 for every decimal value if you want. So we have to add 3 to it. So it will be 000011. Sorry, 0011. That is 0 plus 3. So 3 is 0 plus 3 is 3. 3 represented in binary in 4 bits is 0011. Similarly, if you want for decimal 1, XS3 code for decimal number 1, so it will be plus 3. So it will be 0100. So 1 plus 3 is 4. 4 is represented in 4 bits as 0100. Similarly for 2 it is 0101. For 3 it is 0110. For 4 0111. For 5 1000. For 6 it is 1001. For 7 1010. For 8 1011. For 9 1100. 12. For 9 plus 3 is 12. 12 is represented like this. 8 plus 3 is 11. So 11 is represented like this. 7 plus 3 is 10. 10 is represented by 1010. Similarly 6 plus 3 is 9. So 9 is represented by 1001. Similarly for 5 it is 8. XS3 code is representation is 8. So 8 is represented in binary as 1000. Okay, so for these decimal numbers, these are the corresponding XS3 codes. Right, so for single digits these are the representations. For multiple digits, suppose if you have multiple digits 62, so how can you represent XS3 code of 62? So you have to represent separately the XS3 code. So what is the XS3 code of 6? So XS3 code of 6 is 1001. So it will be 1001. Similarly XS3 code of 2 is 0101. So this will be the XS3 code for 62. Okay, for multiple digits you have to represent separately the corresponding XS3 code. For single digits these are the codes, and for multiple digits you have to represent separately. Right, so suppose if you have 549 base 10, that is decimal number 549, and if you are asked to find the XS3 code, right, so how to write XS3 code? The XS3 code of 5 is 1000. XS3 code of 4 is 0111, and XS3 code of 9 is 1100. So that's all. This will be the XS3 code. Okay, so you can extend it to any number, right? So if you are asked to find, if you are given with decimal number and you are asked to find XS3 code, you can solve like this. right? So XS3 code is the so what is XS3 code? It is a non-weighted code. It is an example of non-weighted code. So each bit position does not have any specific weight. We can't say the specific weight for this position, or for this position, or for this position. You can't say the specific weight. So it is a non-weighted code. Okay, so this is about XS3 code. Next, self-complementing codes. So what type of codes are called as self-complementing codes? Self-complementing codes are also called as reflective codes. Okay, self-complementing codes are also called as reflective codes. So what type of codes are called self-complementing or reflective codes is, so in a code, so representation, okay, by representation for 9 is complement representation. Complement representation for 0. In a code, if the representation for 9 is complement representation for 0, comma 8 for 1, okay, that is representation of 8 is complement representation for 1. Similarly, 7 for 2, 6 for 3, and 5 for 4, then such type of code is called as self-complementing code. Self-complementing code. Okay, so if you take the example of XS3 code, XS3 code is self-complementing code. It is an example of self-complementing code. Okay, I'll explain to you. So what is the code for 0? Code, the code for 0 in XS3 is 0011. Similarly, what is the code for 9? It is 1100. So if you observe here, these two codes are complement to each other. That is, wherever zeros are present in the code for 0, so there you are having ones in the code of 9. So for 0, how we are representing in 0? For the representation of 0 in XS3 code is 0011. Similarly, 9 is 1100. So wherever ones are there, so here in code for code 9 we are having zeros, and wherever zeros are there we are having ones here. So 0 is complement code for 9. So first condition is satisfied. So the code representation for 9 is complement code for 0. Similarly, if you see, 8 is also the complement code for 1. So 8 is represented, 1 is represented by 0100. Similarly, 8 is represented by 1011. So wherever zeros are there, you are having ones here. Okay, such type of code is called as self-complementing. So second condition is also satisfied. It should satisfy each and every condition. So 7 for 2. So even if you observe for 7 and 2, so it is 1010. Here it is 0101. So it is also complement code. Similarly, 3 and 6 is also complement code. Similarly, these two also, 0111 is there, so here 1000 is there. So wherever zeros are there, so you are having ones here, or wherever ones is there, so you are having zeros here. So complement code, the code for 4 is complement code for 5. Similarly, code for 3 is complement code for 6. Similarly, code for 2 is complement code for 7, 1 for 8, and 0 for 9. So each and every condition is satisfied here. Therefore, we can say that XS3 code is a self-complementing code. Okay, so other examples are 2421, 5211 also, 2421 and 5211. These two codes are also self-complementing codes. These are weighted codes, right? So 2421 we have already seen. So they are weighted codes. So they are also self-complementing. So let me write the corresponding values. 0 is represented as 0000. Okay. 1 0001. 2 0010. 3 0011. 4 0 1 0 0, 5 1 0 1 1, 6 1 1 0 0, 7 1 1 0 1, 8 1 1 0, 9 4 ones. So if you observe, the code for 0 is all zeros and code for 9 is all ones. So complement code. So code for 1 is 0001 and code for 8 is 1110, 0001 here, 1110 here. So they are complement codes. So here also 0010 here, here 1101. So 00011 here, here it is 1100, 0011 1100. So both are complement codes. So these two also complement codes. So wherever zeros are there, here 2 zeros, you are getting 2 ones here. 1 is there, so complement is 0. 0 is there, complement is 1. So this is also an example of self-complementing code. Okay. So next, if you have 5211, like if you write the equations for, if you write the representations for this, it is 0000. Similarly 1 0 0 0 1, 0 0 1 1. Similarly 0 1 1 0 for 3, right? For 4 0 1 1, for 5 1 0 0 0, for 6 1 0 0 1, for 7 1 1 0, for 8 1 1 0, for 9 4 ones. So here 4 zeros and 4 ones here. So 0001 1110. So similarly, if you check for other also, so this will also be a self-complementing codes. So any code for which the code representation of 9 is complement for 0, 8 for 1, 7 for 2, 6 for 3, 5 for 4 is said to be self-complementing code. Okay, so let me take one more slide. I'll tell you two very important points regarding self-complementing codes. Okay. So we have seen XS3 code, right? So XS3 code, which is a self-complementing code. So I'll write one more time. Okay. So for 1 it is 0 1 0 0. I'll write fastly. 0 1 0 1, 3 0 1 1 0, and 4 0 1 1, 5 is 8, 6 1 0 0 1, 7 1 0 1 0, 8 1 0 1 1, and 9 it is 1 1 0 0. Okay, so the first important point here is, in all self-complementing codes, nine's complement is obtained by just complementing each bit. Okay, suppose if you have number 9, so it's 9's complement. 9's complement is obtained by subtracting the number from 9. So if you want the 9's complement of 9, so 9 minus 9 is 0. So 0 representation is 0 0 1 1, and 9's representation is 1 1 0 0. So if you want 9's complement of this, so you just have to complement each bit. Okay, so in all self-complementing codes, 9's complement is obtained by just complementing each bit. Okay, so if you are having if you are given with an XS3 code, so suppose XS3 code, okay, so in XS3 code, if you are given with 0 1 0 0, 1 0 0 1, and 1 0 1 1. Okay, so in XS3 code you are given with this, and you are asked to find 9's complement. Find the 9's complement of this XS3 code. So how you are going to find the 9's complement? So what is the representation of 0100 in XS3 code? If 0100 is there, what is its representation? Its representation in decimal is 1, right? Its representation in decimal is 1 here, 0100. So what is the 9's complement of 1? 9 minus 1, which is equal to 8. 9 minus 1 is 8. So 8 in XS3 code is 1011. 8 in XS3 code is 1011. Or just by complementing each bit also, you get the same result. You'll get the same result. So you don't have to find again corresponding decimal here, right? So finding the decimal here and corresponding 9's complement and corresponding again the XS3 value of the new decimal value. So all this thing is not required. If you remember this point, everything is not required. So first of all, what you have to do, you have to find the decimal equivalent of 0100. So 0100 decimal equivalent is 1. So 1 you have found, and next you have to find the 9's complement by subtracting by subtracting this 1 from 9. So 9 minus 1 is 8. Again, for decimal 8, what is its corresponding XS3 code? It is 1011. So this is what you have got. Or this can also be obtained by just complementing these bits. So 0100, if you complement, you will get 1011, like this. Understood? So this is the important point. 9's, if you are given with an self-complementing code like XS3 code or 2421 code or 5211 code, okay, and you are asked to find the 9's complement, you just have to complement each bit. So here also 1001, so 1001, its corresponding decimal value is 6. So its 9's complement is 9 minus 6. 9 minus 6 is 3. So for 3, what is the XS3 code? 0110. Or just complementing also, you'll get the same result. Similarly here it will be 0100. Okay, so remember this point, very important point. If you are given with a self-complementing code, so just complement each bit in that code, you'll get its corresponding 9's complement. Second most important point regarding self-complementing code is if sum of weights, if weighted code is given for you, right? So first point is that if weighted code is given for you and if sum of the weights is equal to 9, if the sum of the weights is equal to 9, then it is a self-complementing code. Simply you can say. Okay, then it is a self-complementing code. Okay, so suppose if you are given with 2421, 5211, 74, 2 bar, 1 bar, or 74, 1 bar, 1 bar. Okay, so these are all weighted codes. When weighted code is given for you, sum of weights means, so sum of all these 2 plus 4 plus 2 plus 1, sum of all these codes, weights. Okay, sum of weights I am telling you. So sum of the weights is 2 plus 4 is 6, 6 plus 2 is 8, 8 plus 1 is 9. So sum of the weights is equal to 9. Therefore we have seen that 2421 is a self-complementing code. So we have just now seen that it is a self-complementing code. Similarly 5211, so it will be 5 plus 2 plus 1 plus 1, so it will be 9. So it is also a self-complementing code. Very important point. If you are given with a weighted code and asked to find whether the given code is self-complementing or not, you just have to sum the weights. If the sum of the weights is 9, then it is a self-complementing code. If sum of the weights is not equal to 9, then it is not a self-complementing code. So suppose if you take this 7 plus 4 minus 2 minus 1, so 2 bar means its weight is minus 2. So 7 plus 4 is 11, 11 minus 3 is 8. So sum is not equal to 9. It is not self-complementing code. Okay, so this 7 4 2 bar 1 bar is not a self-complementing code. Similarly this 7 plus 4 minus 1 minus 1, 7 plus 4 is 11, 11 minus 2 is 9. It is again sum is equal to 9. So therefore this is self-complementing code. Okay, so this is how we can find whether the given weighted code is self-complementing or not. And also you can find the 9's complement by just complementing each bit. Right, so these two are very important points regarding self-complementing codes. Okay.